Hello guys, I'm a teacher Olimboka Sajuga Masame. Let us see the relationship between relative velocity of two objects that are moving along the straight line. Let us consider the motion of bus and the passenger inside the bus that is walking inside while the bus is moving. Hence, we will have two velocity as recorded by observer from the ground. We will have velocity of bus as recorded by observer from the ground, and we will have a velocity of the man as recorded by observer from the ground. And the third velocity is the velocity of man relative to bus, or is the velocity of bus relative to man. Okay, we will have two relativity for this case, and the first relativity is velocity of man relative to bus. This bus is the one that records the velocity of the man, and the one who records the velocity of man is the driver inside the bus that moving with the velocity of the bus. And for other cases is the velocity of bus relative to man. For these cases is man who record the velocity of moving bus. This man, remember, is walking inside the bus that is moving. Okay, let us see how we can get the relationship between these two concept of relative motions. For relative motions, we must set two axes coordinates as a frame of reference. We have first a coordinate origins here, that is 0, 0. This is act as the frame of reference for stationary observer or initial observer or observer from the ground. This observer from the ground will record the absolute velocity for a bus and absolute velocity for a man that is walking inside the bus. Okay, another set of axes as a frame of reference is for moving observer. The moving observer will be a man walking inside the bus or the bus itself. Okay, this set of axes depending with the one who is responsible to record the motion of the others. For this first case, we need to record the motion of the man as observed by the driver inside the bus. Okay, that's why we set the coordinate here. As the driver inside the bus is away from the walking man, hence he will record the motions of the man walking inside the bus as it is away from his set of axes, as you can see here. Hence, we will have three projected vector from our diagram below. The first vector is OA, which is vector of velocity of bus relative to the ground as recorded by this stationary observer. And the vector OB is the velocity of the man with respect to the ground, or as recorded by this stationary observer. And another third set vector is O' to O. Let's say take it as OC. Okay, and this is the third vector. But from vector addition rule, we will have a first vector as this one, and the second vector as this one. And the resultant vector is always drawn from the tail of first vector to the head of the last vector. And it is always the arrangement in drawing the vector diagrams. You must first draw the first vector according to its directions and its magnitudes. Then the second vector is drawing on the head of the first vector according to its magnitude and directions. Then the resultant vector that will be drawn from the tail of the first vector to the head of that last vector. And here is second vector. It's just a vector O A' to C. Okay, and then we will, by applying addition rule, we will add vector OA to O' C which is equal to resultant vector OB. As you can see here, the vector OA is velocity of bus relative to the ground, plus a vector O-C is the velocity of man relative to bus, which is equal to velocity of man relative to ground. Then always this velocity of man relative to bus is negative, as observed by this moving observer inside the bus. This is the driver. And by justifying this through displacement, we know that to get this resultant displacement as observed by this observer inside the bus, the driver, will be equal we take the final positions, we minus with initial positions, then we divide it by time during that when the motion is recorded. Then the initial displacement is from O to A. The initial displacement, then the final displacement is from O to B, and then when we take final displacement OB minus this OA, then we divide it with time. Time just is time for observer A, who records the whole motions. That's the O to A, as here. Then this is less as OB is less displacement, and OA, this is the great displacement. So always the value of velocity of man relative to bus will be negative. Thanks for watching. Please comment, like, share. Don't forget to subscribe for more videos like this one. Thank you.